Hello everyone, this is Dr. Sumit Chauhan and we are discussing data link layer. The concept that we have for today is switching. Now switching, when there are many devices, it is necessary to develop suitable mechanism for communication between any two devices. In the switched network methodology, the network consists of a set of interconnected nodes among which information is transmitted from source to destination via different routes, which is controlled by the switching mechanism. The end devices that wish to communicate with each other are called stations. The switching devices are called nodes. Some nodes connect to other nodes and some are to connected to some stations. The switching performed by different nodes can be categorized into the following three types. We have circuit switching, packet switching, and message switching. Circuit switching. Communication via circuit switching implies that there is a dedicated communication path between the two stations. The path is connected through a sequence of links between network nodes. On each physical link, a logical channel is dedicated to the connection. Circuit switching is commonly used technique in telephony, where the caller sends a special message with the address of the callee to state its destination. It involved the following three distinct steps. Circuit establishment, the first one, to establish an end-to-end connection before any transfer of data. Some segments of the circuit may be a dedicated link, while some other segments may be shared. The second step is data transfer. Now, when you have circuit has been established, you can transfer the data. Transfer data is from source to the destination. The data may be analog or digital depending on the nature of the network. The connection is generally full duplex. Third and final step would be circuit disconnect. Terminate connection at the end of data transfer. Signals must be propagated to deallocate the dedicated sources. Thus, the actual physical electrical path or circuit between the source and destination host must be established before the message is transmitted. This connection, once established, remains exclusive and continuous for the complete duration of information exchange, and the circuit becomes disconnected only when the source wants to do so. The next is message switching. In this switching method, a different strategy is used where instead of establishing a dedicated physical line between the sender and the receiver, the message is sent to the nearest directly connected switching node. This node stores the message, checks for errors, selects the best available route and forwards the message to the next intermediate node. The line becomes free again for other messages while the process is being continued in some other nodes. Due to the mode of action, this method is also known as store and forward technology, where the message hops from node to its final destination. Each node stores the full message, checks for errors, and forwards it. In this switching technique, more devices can share the network bandwidth as compared with circuit switching technique. Temporary storage of messages reduces traffic congestion to some extent. Higher priority can be given to urgent messages so that the low priority messages are delayed while the urgent ones are forwarded faster. Through broadcast addresses, one message can be sent to several users. Last of all, since the destination host need not be active when the message is sent, message switching techniques improve global communications. Each network node receives and stores the message, determines the next leg of route, and queues the message to go out on that link. Advantages: line efficiency is greater, data rate conversion is possible, even under heavy traffic, packets are accepted, possibly with a greater delay in delivery. Message priorities can be used to satisfy the requirements, if any. Talking about disadvantages, message of large size monopolizes the link and storage. The last one is packet switching. The basic approach is not much different from message switching. It is also based on the same store and forward approach. However, to overcome the limitations of message switching, messages are divided into subnets of equal length called packets. In packet switching approach, data can transmit in short packets. A long message is broken up into a series of packets. Main difference between packet switching and circuit switching is that the communication lines are not dedicated to passing messages from the source to the destination. In packet switching, different messages can pass through different routes, and when there is a dead time in the communication between the source and the destination, the lines can be used by other sources. There are two basic approaches commonly used to packet switching: virtual circuit packet switching and datagram packet switching. In virtual circuit packet switching, a virtual circuit is made before actual data is transmitted, but it is different from circuit switching in a sense that in circuit switching, the call accept signal comes only from the final destination to the source, while in case of virtual packet switching, this call accept the signal is transmitted between each adjacent intermediate node. An initial setup phase is used to set up a route between the intermediate nodes for all the packets passed during the session between the two end nodes. In each intermediate node, an entry is registered in a table to indicate the route for the connection that has been set up. Thus, packets passed through this route can have short headers containing only a virtual circuit identifier (VCI) and not their destination. Each intermediate node passes the packets according to the information that was stored in it in the setup phase. Datagram packet switching networks. This approach uses a different, more dynamic scheme to determine the route through the network links. Each packet is treated as an independent entity, and its header contains full information about the destination of the packet. The intermediate nodes examine the header of the packet and decide to which node to send the packet so that it will reach its destination. Thus, in this method, the packets don't follow a pre-established route, and the intermediate nodes don't have predefined knowledge of the routes that the packet should be passed through. Packets can follow different routes to the destination, and delivery is not guaranteed, although packets usually do follow the same route and are reliably sent. Due to the nature of this method, the packets can reach the destination in a different order than they were sent. Thus, they must be sorted at the destination to from the original message. This approach is time consuming since every router has to decide whether to send each packet or where to send each packet. The main implementation of datagram switching network is the internet, which uses the IP network protocol. Packet switching. Talking about advantages, call setup phase is avoided because it is more primitive, it is more flexible. Congestion failed, link can be avoided. Problems, packets may be delivered out of order. If a node crashes momentarily, all of its queued packets are lost. And here we are have the difference between circuit, datagram packet, and virtual circuit packet switching. So in circuit switching, you have a dedicated path, datagram packet no dedicated path, virtual circuit no dedicated path. Then we have path established for entire conversation. That is the first thing that we have to do in circuit switching. Circuit establishment would be the first step. Then route established for each packet separately. route established for entire conversation. Thanks for watching.